to motivate why we would like the equation x squared plus 1 equals 0 to have solutions, and that, of course, is just equivalent to x squared equals minus 1. Let's go back to an example that we used when we first introduced exponents in part 1 of our course. We observed that one of the properties of a equation like y equals e to the rx, where r is a constant, is that if we differentiate this with respect to x, the r comes down, but the factor e to the rx remains. What this told us was that in taking derivatives, we would get powers of r, but e to the rx would remain, and we used that technique for solving certain types of differential equations. For example, looking at the equation y double prime plus y equals 0, one technique would be to replace y by e to the rx. When I differentiate twice, I have an r squared e to the rx here. Here is an e to the rx. The e to the rx cancels out, and I wind up with a polynomial equation for r, and we then solve for the values of r such that this would be a solution of this. Now, back in part 1, because we didn't know non-real numbers, we always fixed it up so that the resulting equation that we got here would have real numbers for values of r. By the way, I have chosen this particular equation because for two reasons. One is the values of r can't be real when I get through here. The other is I already know an answer to this problem. Remember that if you differentiate sine twice, you get minus sine. If you differentiate cosine twice, you get minus cosine. Consequently, the second derivative of sine x plus sine x is 0. Second derivative of cosine x plus cosine x is 0. So I know at least two solutions to this equation, two real solutions to this equation. This equation has physical meaning because it essentially says if you think of the parameter as being time here, look at the second derivative is equal to minus the function itself. That says that the acceleration is equal to minus the displacement, and that's a form of simple harmonic motion. You see, what I'm trying to establish here is that this does have a real solution, and the problem itself has real physical significance. At any rate, if we now try to solve this problem using this technique, and remember, again, I can give you problems where we won't know the answer intuitively, and the values of r will still come out to be imaginary. I simply chose this problem so that we could correlate a so-called imaginary answer with a real answer. The idea, again, is I differentiate e to the rx twice, I get this. So y double prime plus y is this. I factor out the e to the rx, which can't be 0. Therefore, it must be that r squared plus 1 is 0, or r is equal to plus or minus the square root of minus 1. Now, you see, so far, I don't know what this thing means because there certainly is no real number which has this property because the square of real numbers have to be positive. They can't be minus 1. Let me, for the sake of argument, invent a number which is equal to the square root of minus 1. I'll call that number I. So r is equal to plus or minus I. And if I now remember what equation I'm solving, it was y equals e to the rx. I can replace r by either I or minus I. So the two solutions that I would get would be y equals e to the ix or y equals e to the minus x. But this is bothering me because I really have no real feeling for what I means right now. What I do know, however, is this, that mechanically this is a solution to a real problem. Y double prime plus y equals 0 was a real problem, not an imaginary one. And by the way, notice mechanically here, taking I to be a constant, if we still assume that the derivative of e to the rx is r e to the rx, even when r happens to be non-real, notice that if I differentiate this thing twice, the first time I differentiate, I bring down an I. The second time I differentiate, I bring down an I. That gives me I squared, which is minus 1. This is going to be minus e to the ix. And if I add on e to the ix, I really do get 0. Notice also now that I do know that a real solution of this equation is y equals cosine x, or also y equals sine x, so that somehow or other I get the feeling that I should exist, and more to the point that this expression e to the ix should somehow be related to sine x and cosine x. In other words, if I had never been lucky enough to invent the trigonometric functions, and I wanted to solve the problem y double prime plus y equals 0, and wound up with this, then my feeling is I must find a real interpretation, physically real interpretation, for e to the ix, because I sense that my problem has a solution. Again, I can take the coward's way out. I can say, if it's going to be this much work, I don't want the problem to have a solution.